In this video, I'm actually going to argue that we aren't omnivores. In fact, there is a little bit of a clear indicator as to what we are, but in order to do this, we are going to have to look at this through two perspectives. First, we're going to have to look at this through an anthropological perspective. For instance, we're going to have to look at our ancestors. More specifically, we're going to be looking pretty much tens of thousands of millions of years ago, even up to 10 million years ago. And then after that, we will be looking at the digestive system in order to understand. Now, first, actually, we will start with the digestive system, and we will see, based on the digestive system of both herbivores and carnivores, and not only that, maybe even a little bit of omnivores, we will see what our digestive system looks like. First, let's look at the two kinds of digestive tracts. More specifically, let's look at the digestive tract of a carnivore, and then afterwards an herbivore. And afterwards, we will even look at an omnivore a little bit, and we will see that omnivores don't really exist in nature. Well, they do, but it's a little bit different. It's more so about opportunity. First, let's look at the carnivore digestive system in order to understand what exactly makes a carnivore, and what are some of the main traits that make a carnivore carnivorous. First, we already know that carnivores do seem to have a little bit of these sharp teeth. Now, we also know that carnivores have a difficult time moving their jaw side to side, more specifically doing a grinding motion with their teeth while they are clenched. So, in order to test whether or not that animal is a herbivore or a carnivore, in order to see whether or not they are more leaning towards carnivory, we would basically clamp their teeth together and we will see the range of motion that they have. And if they lack range of motion and they can't move their jaw from very far side to side, so for instance, all the way over here, or all the way over here when they're chewing, then that means that they are not an herbivore, they are a carnivore. Secondly, we already know that the digestive tract of carnivores are actually single chambered, and not only are they single chambered, we also know that the acidic conditions of the carnivore stomach are extremely acidic. They are actually around 1 to 2 pH. Now that is extremely low, and that means very, very high acidity. Now this is what basically allows for them to eat meat, and as well as deal with the bacteria that comes with it, because there could be some problems in the process of eating all that meat, and if there are bacteria, for instance, then they can actually contaminate and pretty much mess with the carnivore stomach. So this is why the pH is very, very low. The third main trait about the carnivore digestive tract is actually that their small intestines are very, very small. Actually, they're only around 3 to 6 times the body length, which is not really that much in comparison to herbivores. Now, the fourth factor that actually makes an animal a carnivore, and this is the most important factor, is whether or not they do or they do not have a cecum. Now, a cecum is pretty much just this pouch that can harbor tons of this bacteria, and this bacteria is able to ferment and basically turn that fiber into usable material, which we will talk a little bit about later. And the final and fifth trait about a carnivore is the fact that they actually have a large intestine that is not really so large. It's a little bit short and it's smooth. So that is the main traits about a carnivore animal and what makes an animal lead towards carnivory. Now we'll be looking at the herbivore's digestive tract. Now we already know that the herbivore digestive tract actually has a couple main factors. First off, we know that their teeth are actually very, very high in terms of the range of motion, and that's because they don't have basically a ridge on their teeth, and they are able to move their teeth side to side very, very well. So when they are chewing pretty much all the way over here and all the way over there with their teeth. And the reason that herbivores are actually able to chew with such a long range of motion from side to side is because they need to be able to degrade that fiber as much as possible, because that fiber is very, very difficult to break down, and that's where they get most of their energy. The second trait about an herbivore that makes an herbivore is their stomach. Now their stomach can either be single chambered, or it can actually be very, very complex and basically multi-chambered, which is similar to that of a cow or a deer. Basically, the multi-chambered stomachs are those of ruminants, and the reason they have multiple chambers is because degrading and breaking down fibrous material is very, very difficult. The other thing that we know about herbivores' stomach pH is actually they are very, very high in comparison to that of carnivores. And that means that their stomach pH can be around 4 sometimes, which is quite high. And this is probably because, once again, they don't have to deal with this bacteria in comparison to carnivores. And because of that, they can probably have higher stomach pH. The third thing that makes an herbivore an herbivore is the fact that their small intestine is actually 10 to 12 times their body length, which is very, very long in comparison, because if we compare that to the carnivore, it is extremely long. That is literally about 2 to 3 times the length of a carnivorous animal. So that's pretty long. Now, the fourth and the main factor that actually makes an herbivore is the fact that they have a cecum. Now, a cecum is pretty much something that is able to harbor tons of bacteria, and while it's harboring tons of this bacteria, it is able to basically ferment and break down that fiber. And this is, once again, the main source of energy for herbivores, which we will talk about later, and you'll be able to see why this is the really determining factor in terms of what makes an herbivore an herbivore. Now, the fifth factor that makes a herbivore's digestive system is the fact that their large intestine is actually very, very large. It's large. And the reason why it's so large is because it has to be able to account for extra fermentation. Now, if the herbivores did not have this, then they would be similar to that of carnivores. And we will compare these two, specifically herbivores and carnivores, and we will see that humans are either herbivores or carnivores. Now, the reason why omnivores don't really actually exist is because omnivores are opportunistic. Actually, every animal is omnivorous, technically speaking. And this is because a deer can quite literally eat birds. Yes, deers will eat birds if they have the chance, or even chimpanzees will end up eating little monkeys. Now, this is very, very common, and in terms of nature, pretty much everything is opportunistic. If they have the opportunity to do so, they will take the opportunity. Now, this is actually going to be what makes the main contributing factor to what makes an animal either herbivorous or what makes it carnivorous. And it is, how is it getting its fatty acids? Now, when it gets fatty acids are actually the primary energy source of the cell. And if you don't know the reason why, then go check out my channel, because I'll explain it in a lot more detail there. But to keep it short, fatty acids are the primary energy source. And the reason they're the primary energy source, to keep it very short, is because, one, they produce 3 times more ATP energy than glucose, and they produce way less reactive oxygen species, which are very damaging for the cell and the animal. So yeah, they're called reactive oxygen species. They're reactive. Now, in terms of fatty acids, specifically for that of carnivores, they get it from meat, and they get it from the fat and the protein that they are eating, which is found in meat. So, for instance, that could be in your ribeye steak. Now, obviously, all of the nutrition doesn't come from just the ribeye. They usually eat a lot of other parts of the animal, but regardless, this is how carnivores get their energy. They get it mainly through fatty acids as well. And herbivores do the exact same thing, for that matter. In fact, the only difference between herbivores and carnivores in terms of where they get their fatty acids is that herbivores get their fatty acids specifically from fiber. So this is exactly where they get their fatty acids from. They get it from fiber. And in order for them to break down this fiber, because it's very, very difficult to actually convert this fiber into energy, they need a cecum, which is exactly the main part that I mentioned before about what makes an herbivore herbivorous and what makes a carnivore carnivorous. This is it. It's whether or not they have a cecum, and whether or not their cecum is actually usable, because in order for them to get fatty acids, they need a cecum. And if they don't have a cecum, then they're going to have to eat meat. And if they don't get it from meat, they can't really survive in nature, because nature does not have glucose usually flying about. There are some very, very rare exceptions, like hummingbirds, for instance, but for the most part, they're pretty much minimal and non-existent. Now that we know what makes an herbivore herbivorous and what makes a carnivore carnivorous, we are going to be looking at the digestive tract of humans. Now, humans, we already know, do seem to have bicuspid teeth, which basically means they can't necessarily move their mouth with really long range from side to side when it comes to chewing. So they can't actually degrade much of the fibrous material. And if you try this yourself, and if you just try to clench your teeth down and move them side to side, you can't do that. And that's because there are little ridges in your teeth that prevent that from happening. Now, herbivores, on the other hand, their teeth are pretty much flat. So because they're just flat, they are able to actually move their jaw from side to side all the way over here while chewing like this. We can't do that. Or Alright, you get the point. So yeah, that is what leans us towards one trait specifically though, that leans us towards carnivory. Now, this isn't just the only trait because there are 4 others. So we will be looking at the 4 other traits and seeing whether or not we lean towards one or the other more. Now, the second thing that we covered is the stomach of herbivores and carnivores. Now, we already know that the stomach of both herbivores and carnivores are greatly different for a couple of reasons. One of which, some of them are ruminants, meaning they are very, very complex, and some of them are single chambered. Now, because they can both be single chambered, this is where we have to look at the stomach pH of both animals. Now, in our case, we already know that our stomach pH does seem to actually line around 1 to 1.5, maybe even 2 if you're a little bit on the high end. And this actually leans us once again towards carnivory, because remember, carnivores do seem to have a stomach pH of around 1.5 to 2. So we are actually very, very low in terms of the stomach pH, and there's a reason for that. I'm not going to be going into that in this video, but yeah, our stomach pH is extremely, extremely low. So that is another trait that leans us towards carnivory, giving carnivory 2 points now. The third factor that determines whether or not us humans are either herbivores or carnivores is whether or not our small intestine is small. Or not so small. Now, our small intestine is around 4 to 6 times the length. Now, if you remember, an herbivore actually has a stomach length of around 10 to 12, which is quite long. And a carnivore has that of 3 to 6. Now, we fall in the category of 4 to 6. So that already makes us lean, once again, more so towards carnivory. So we will once again put another point towards carnivory. Now, the fourth and basically the main factor that determines whether or not an animal is carnivorous or is not carnivorous has to do with the fact of whether or not they have a cecum. And because, once again, as we talked about before, short chain fatty acids and fatty acids just themselves are the primary fuel source of the cell. And once again, I'm not going to go into the super details about that. And if you're really interested, go check out my channel because I talk all about it in my channel. So, what do human cecums look like? More specifically, do humans even have cecums in order to basically get energy and get value out of that fiber? Well, it turns out we do not, actually. We have something called an appendix, which is basically a residual cecum, meaning that it used to exist, or a cecum did seem to used to exist there, but now it does not exist anymore. And probably the reason why is the fact that we can't actually derive and get any value out of fiber. And because we can't derive and get much value out of fiber, this is a big deal, because this means that us, specifically humans, eating fiber is basically completely useless, because there is no benefit to fiber whatsoever. And fiber is actually a little bit damaging for that matter, especially if you don't have a cecum. So yeah, I would avoid it. If you're really interested, once again, in the details behind that, go check out my channel. And the fifth and final factor of whether or not humans are either herbivorous or carnivorous is whether or not their large intestine is large or small. Now, even though it's called the large intestine, once again, it doesn't necessarily mean that it's large. Now, if we look at the human's large intestine, we will see that the human's large intestine is actually not so large. In fact, it's small. So we can already put 1 point towards carnivory there. Now, even though this is the digestive tract of humans, and we see that humans clearly do seem to lean towards carnivory in terms of their digestive tract, what about the historical aspect? I mean, what did humans eat, right? Didn't we grow up eating maybe fruits or any of that sort of thing? Well, we're going to look at history, more specifically anthropology, and we're going to be able to see, based on anthropology data, whether or not humans were either herbivorous or carnivorous in their evolution, and whether or not they did grow to eat tons of these fruits, or did they grow up hunting, or did they grow up doing both? So we already know actually that humans did evolve from Miocene hominids, which is basically another way of saying apes and chimps and primates, that sort of a thing. Now, the interesting thing about these Miocene hominids is the fact that pretty much for about 80% of human evolution, for that matter, does seem to originate from Miocene hominids. So this would lean, or this would be an indicator that we are actually end up eating tons of this fiber and tons of this fruit. But let's look at it a little bit closer and let's understand more specifically the evolutionary timeline. So we're going to be looking at not just Miocene hominids, but the next one after Miocene hominids, which we did seem to come from, specifically Australopithecus. Now, the next one is Australopithecus after Miocene hominids. Now, we did seem to originate a little bit from Australopithecus, and once again, what did Australopithecus eat? Well, we know that Australopithecus was actually definitely grazing quite a bit, especially on those leaves and tons of that stuff. And in order to do so, not only that, it also did do something a little bit more interesting. It was the fact that they made kind of tools, and these tools were actually used in killing other animals, which is very strange. But yes, these tools actually did exist, and they were used in killing other animals, and they did leave a little bit of markings, and this is how we're able to tell that Australopithecus did seem to do this. Now, the difference between Australopithecus and Miocene hominids does seem to be the fact that Australopithecus actually did eat a little bit of small animals, similar to that of chimps for that matter. Now, after Australopithecus does come early Homo sapiens. Now, this is around the time of the Ice Age, and this is when actually brain size started to skyrocket out of control. Now, to name some examples of early Homo sapiens, they could be things like Homo habilis, Homo erectus, or even Homo rudolphinus. Now, every single one of these were early Homo sapiens, and their brain sizes were increasing significantly. And something very interesting, actually, about early Homo sapiens was the fact that they were using tools much more often, and their tools were a little bit more crafty, but they weren't necessarily anything that special. Now, after early Homo sapiens comes Middle Pleistocene Homo sapiens, which some of you might have heard of before, and that is where the Neanderthals come from. Yes, Neanderthals come from Middle Pleistocene Homo sapiens. Now, we know that Middle Pleistocene Homo sapiens actually did, one, do tons and tons of hunting, and two, we also know that they were really chowing down on meat, and I mean a lot of meat, because if you look at these stable nitrogen isotope studies, we can see that their diet consisted primarily that of meat, around 80% of the time meat, and 20% of the time it was tubers. Now, as you might have heard me talk about before a little bit, we do know that opportunistic carnivory basically exists in nature, and even deers or chimps for that matter, if they have the opportunity to, they do seem to take that path and opportunity of eating another animal. We also know that Middle Pleistocene Homo sapiens not only were chowing down on meat, they were actually working in higher numbers, for instance, and they were able to cooperate a little bit better with each other. And not only that, they also did use tools that were much more advanced, especially in comparison to the early Homo sapiens. Now, this is the final part, and this is the part that we are at today, Homo sapiens. Now, that brings us to today, actually, because after Middle Pleistocene Homo sapiens comes us, Homo sapiens. Now, we know that Homo sapiens did actually seem to, one, eat quite a bit of meat, because early Homo sapiens were pretty much that of Neanderthals, almost no different when it comes to stable nitrogen isotope studies. And we also know that early Homo sapiens did have some interesting things, like they were able to work in much higher numbers in comparison to their relatives, which is very interesting. And this is probably the thing that separates the Homo sapiens from Neanderthals, for instance. Now, there was something interesting in the Homo sapien timeline that did seem to indicate a little bit of something going wrong with them. And it's the fact that, as you can see, their brain size was actually shrinking. Yes, and I mean shrinking at such a dramatic rate. And this is a really big deal, because around this exact same time, humans did do something a little bit interesting too. This happened around 12,000 years ago, which is the agriculture revolution. Yes, the agriculture revolution was a massive hit, and it did actually allow for some pretty amazing things, because one, humans were able to work in much larger numbers, which actually gives us civilization that we have today. But two, there was a little bit of a problem, and it came with the catch that it actually diseases and things that didn't originally exist even in humans at all. For instance, malocclusion of the teeth, tooth decay, inflammation of the gums that didn't exist whatsoever before actually did start to exist. So that is a little bit of a problem and not necessarily something that's good. And only once the agriculture revolution actually came about, it did seem that humans did actually end up having all of these problems, whether or not it be the oral problems like tooth decay and basically malocclusion of the teeth, or even the diseased states of today, because those didn't actually exist in the past and those didn't exist for humans. Now, even though historical evidence as well as the digestive tract do seem to align with being that of carnivory, there is some even more interesting evidence that carnivory did even exist a little bit in civilization for that matter. There are actually two examples. The first example is the Ethiopian king talking about it, and the second example is actually the Mongolians themselves. Yes, the Mongolians before were actually highly carnivorous, and it's what made them not just successfully destroy every single other person, pretty much, or every single other civilization, but it's what made them thrive. First, let's talk about the Ethiopian king, more specifically, the conversation between the Ethiopian king and that of the Persian king. Now, Herodotus was the one who was documenting all of this at the time, and he was pretty much the one who actually chronicled all of this and wrote it down for us in order to read it. Now, something interesting did actually happen between the Ethiopian king and that of the Persian king. Now, the Ethiopian king pretty much asked, well, King of Persia, what do your people eat? And the King of Persia ended up saying, well, you know, our people basically grow bread and they basically till the soil. And in doing so, they get bread and they eat the wheat and basically eat the bread. And our people live to about 70 to 80 years of age. And that made the Ethiopian king laugh because the Ethiopian king found that hilarious. Yes, that was absolutely crazy. And why exactly did that happen? Because the Ethiopian king looked back at him and said, well, of course your people are going to live only until maybe 70 or 80 years of age if you people eat nothing but dirt. Our people live to around 120 years of age, if not longer. And not only that, we eat only boiled meat from our livestock. And not only that, we drink the blood as well as having a little bit of milk from them as well, which is very, very interesting. Now, this claim actually is oddly enough supported by genomic data. Yes, because turns out that humans, based on genomic data, are actually supposed to live at around 120 to 150 years of age. So that is very, very interesting because if we actually look at the genomic data, it actually aligns with what the Ethiopian king says. So that's pretty crazy. But what about the Mongols? More specifically, what was the whole thing with the Mongols? Apparently, they were carnivores, right? Well, yes, the Mongols actually were carnivores, and the reason why is because when they were doing their whole Mongol thing up there around Russia, they actually couldn't really forage at all because they were in the plains. And the only thing that they could actually thrive on and survive on was pretty much their horse's blood and a couple of other things, basically meat. And the problem is that in order to do so, they had to basically stick the horse. They would basically jab the horse, and then they would drink the blood from it. It was sort of like a vampire kind of not a symbiotic relationship, more so parasitic. But regardless, yeah, they ended up doing that, and that's how they survived off of the horses. Now, we actually do see evidence of this as well when it comes to the tribe of the Samburu, for that matter. In Africa, they almost do the exact same thing. They don't necessarily ride their livestock. I'm pretty sure they have like goats or whatever. They don't necessarily ride their livestock, but they do end up doing the same thing when it comes to basically jabbing the goat and drinking the blood from it in order to get a lot of their nutrition. Now, this is very, very interesting because this actually might explain a little bit as to why Mongols were the primary and pretty much the dominant civilization, probably argued to be the strongest civilization of all time to ever exist. Now, if you're interested in all of that and why exactly the Mongols were so successful, more specifically, how exactly is drinking blood and all of that supposed to make them even better at everything, then I recommend you check out my Science Behind Carnivore playlist because I explain all of the biochemistry behind it. And yes, it really does work. It's actually shocking how well it works. Now, let's end with some key takeaways. First, we already know that the human digestive system shares more characteristics with carnivores than it does with herbivores. 2, we also know that fatty acids are the primary energy source, not glucose. And most animals, as a general rule, like definitely a large majority of them, do run off of fatty acid. They don't run off of glucose. There are some very rare exceptions, like hummingbirds, for instance, which sometimes will actually have to rely on glucose. They don't really have much of a choice. Third key takeaway is that human brain size has been dramatically increasing, and only actually since the time of the agricultural revolution did it actually seem that human brain size decreased. 4, we already know that the agricultural revolution coincided with all of the diseased states as well as malocclusion, tooth decay, and inflammation of the gums as well. 5, we know that historical records actually do seem to align quite well with that of genomic data, which is very, very interesting because when it comes to history and science, aligning, that is usually not quite common. 6, as a little bit of an addition to number 5, human lifespan based on genomic data does seem to be that of around 120 to 150 years of age. 7, successful civilizations, for instance, the Mongols, basically thrived off of carnivory, and they were actually more so vampires, I would say, but regardless, they were eating meat and blood. I would definitely align that of vampires though. So you could just say they were vampires. Yeah. And key takeaway number 8. We know that the modern diet of today actually does not align with what we ate before, not just in terms of the anthropology, but also our digestive tract, because we know that actually the primary energy source is not just fatty acid. We also know that for some reason we don't have a cecum, and because of that we can't actually basically just eat leaves off of a brush or eat leaves off of a tree and get any energy for it. And if you do try to do so, you might end up dying. So I don't recommend that. Yeah. Once again, thanks for watching. If you found the video informative and really interesting, then please check out my channel, like, share, subscribe, comment down below. It really does help the channel grow. And if you want to see all of my videos ahead of time, then please click the join button down below, where you can see all of my videos ahead of time, as well as support me personally. So once again, thanks for watching. I'll see you in the next one. Peace. Pew.
Break down.